Whether you're a tech enthusiast, industry professional, or just curious about the future of AI Agents Unleashed will keep you informed and inspired. Buckle up and get ready to unleash the potential of AI.
Welcome back, everyone. Ready for another deep dive? Today, we are looking into AI. Specifically, how can we make these powerful language models even smarter without needing a supercomputer for them?
It's a big challenge for sure. As these AI models become more complex and gain millions or even billions of parameters, training them starts to require a ton of resources and computing power.
It's almost like trying to run a huge program on a tiny little computer.
Right. The hardware just can't handle it.
Well, that's where this new research from Google DeepMind comes in. Their paper, Mixture of a Million Experts, looks at a totally different approach to AI architecture.
Yeah, they're moving away from the traditional model of having a single massive neural network, and instead they're proposing a network of smaller, more specialized modules, so basically like a team of experts.
So instead of having one giant brain trying to handle everything, you have a network of smaller brains, and each of those smaller brains has its own specialty.
Exactly. And what's interesting is that this approach, using many smaller experts, seems to be more efficient and could even be more powerful.
But wouldn't managing a million experts be incredibly complex? I mean, just keeping track of them all, let alone making sure they're trained well.
That was the main thought for a long time. But DeepMind's new architecture, which they call PEER, seems to have found a way to do it. PEER stands for Parameter Efficient Expert Retrieval, and it's a really clever combination of techniques designed to deal with this whole million expert challenge.
Okay, let's break down PEER a little bit.
Yeah.
One of the key things they talk about is product key retrieval. What is that?
Okay, imagine a huge library with millions of books, each one representing a specific skill or knowledge. Product key retrieval is like having a super efficient way to find the exact book you need instantly, or in this case, the right expert for a given task.
So you're saying it's all about quickly identifying and activating the most relevant experts when a specific problem pops up.
Exactly, and here's the interesting part. DeepMind found that using really tiny experts, each one with just one neuron, actually worked incredibly well.
So instead of a few large experts, we have a whole network of these tiny specialized neurons all working together. So is it the number of experts that matters, or is there something unique about these single neuron experts?
It seems to be a little bit of both. Individually, those neurons are simple, but the real power comes from how they interact with each other. And because they're so small, it's incredibly efficient to train them and manage them.
That's so cool how this approach really mirrors the concept of distributed intelligence.
Right.
The idea that really complex behavior can come from the interaction of lots of simple agents.
Absolutely. And PEER takes it even further. They use what they call multi-head retrieval, which you can think of as running many searches at the same time to find the absolute best team of experts for a task.
So it's not just about finding any expert. It's like assembling the A-team, perfectly tailored to that specific job.
Exactly. And the results show it works. In their experiments, DeepMind found that PEER consistently beat traditional models and even other mixture of experts approaches across a whole bunch of different language tasks.
Wait a minute, if we have a million experts, are we actually using all of them? Or are there some just sitting around doing nothing?
That's a great question, and the researchers actually looked into that in their paper. They found that with the right techniques, like using something called batch normalization, almost all of the experts are actively involved in the learning process.
So there's no expert left behind.
Yeah.
They're all contributing in their own little way to make the AI model smarter and more efficient, which is incredible. But what does this actually look like in practice? What specific tasks were these PEER models tested on? And how well did they do?
That's a great question and a perfect segue into the next part of our deep dive. We'll take a look at the language tasks that were used to test PEER and unpack those impressive results DeepMind got to. Stick with us. All right, welcome back. So let's dive into these tests that DeepMind used to see how good PEER really is. They wanted to know how this new architecture would do when compared to the traditional models.
Yeah, let's hear about these language tasks. What were they looking at?
Well, they focused on some of the most popular language modeling datasets. Each one is meant to challenge the AI in different ways. You can think of these datasets as massive libraries of both text and code. That's where the AI models learn how to understand and generate human language.
So it's like giving the AI a really intense course in everything about language, right? From basic grammar and vocabulary all the way up to complex ideas and reasoning.
Yeah, exactly. What were some of the specific data sets they used? Well, one was the curation corpus, which is a collection of like the highest quality text and code. The idea is to train the AI on the best stuff out there, the most accurate and well-written sources, so it learns from the best.
Yeah, that makes sense. You want to make sure the AI is getting a good education, so to speak. What else?
They also use something called Lambda. This one focuses on the model's ability to understand long-range dependencies in text.
Okay, hold on. Long-range dependencies sounds a little complicated. Can you explain that a bit more?
Sure, it's about understanding the connections between words and phrases that might be separated by lots of other words. You know how the beginning of a sentence can totally change what a word means at the very end? Lambda tests whether the AI can figure out those connections.
So it's not just about knowing each word by itself. It's about understanding how everything fits together in the whole text.
Yeah,
Kind of like how we as humans understand a story or article, right?
exactly. Then there's the pile, which is a massive data set that takes information from a ton of different places, like books, websites, code repositories, everything you can imagine. The pile basically throws every kind of text at the AI.
So the AI is exposed to as much different information as possible. I guess the goal is to make a more well-rounded AI that can handle all kinds of language tasks.
Exactly. And of course, they used Wikitext, which is a data set based on Wikipedia articles. This one is about how well the AI understands and generates factual, informative text.
Oh, so basically, can the AI write like a Wikipedia editor? That's a pretty good test to see if it knows stuff and can write well. And didn't they also use the C4 dataset, the one they did the ISO all-flop analysis with?
You got it. The C4 data set was really important for comparing how efficient the different models were when they all used the same amount of computing power.
Okay, so we've got a good mix of datasets, each one testing different parts of language understanding and generation. But how about the results? How well did Peer actually do?
Now, this is where it gets really interesting. Across all of these data sets, Peer was better than the traditional models, and it even beat other mixture of experts approaches.
So it wasn't just lucky or good at one thing. Peer was proving itself across all these different challenges.
Right. And remember, we talked about perplexity as a way to measure how good a language model is. Basically, lower perplexity means the model is better at predicting language and understanding all those little details.
Right. It's like measuring how surprised the AI is by the text.
Huh.
Less surprise means it understands better.
Exactly. And Peer had lower perplexity scores than the others across the board. For example, on the curation corpus, Peer had a perplexity of 20.68 compared to 23.26 for a traditional dense model.
So a pretty noticeable difference right from the start. What about the other MOE model, the one with bigger experts?
That one scored 20.98 on the curation corpus. So it was still better than the traditional model, but not as good as Peer. And this pattern continued for all the other data sets too.
So Peer was consistently getting lower perplexity scores, which means it's better at understanding and predicting language. That's pretty amazing. But these are all kind of technical measurements. How do these results actually play out in the real world?
That's the big question, right? It's not just about passing tests. It's about building AI that can actually do useful things in the real world. So we need to understand how these language tasks connect to real world stuff.
Okay, I'm ready for an example. How do these tests connect to something we might use every day?
Well, take the Lambda dataset, which focuses on long-range dependencies. Being able to understand those connections is super important for things like machine translation or summarizing text. If the AI doesn't get how different parts of a text relate to each other, it's going to have a tough time with those tasks.
Right. To translate a complicated sentence or summarize a long article, you need to be able to see the whole picture.
Exactly. And the Wikitext dataset tests whether the AI can write informative text. That's important for things like writing articles, creating educational content, or even answering complex questions.
So all the data sets they use to test Peer are actually testing skills that are really relevant to the AI applications we're seeing pop up everywhere.
Absolutely. As AI models keep getting better, we can expect to see even more advanced and helpful applications in fields like healthcare education, scientific research, you name it.
This is all so cool. We've covered the data sets, the metrics, the results. It's pretty clear that Peer is a big deal in the world of AI.
Yeah.
But where do we go from here? What's the bigger picture?
That's the perfect question to get us started on the final part of our deep dive. We'll move beyond the specifics of Peer and talk about what this research means for the future of AI in general. Stay tuned.
Okay, so we've seen how well Peer actually performs. But I'm thinking about the bigger picture now. What does this research tell us about the future of AI?
That's what's really exciting. This isn't just about making things a little better. This could change the whole game when it comes to developing and using AI.
Okay, let's talk about those big changes.
Yeah.
What are some of the most important ways this work might impact things?
Well, one of the most exciting parts is that it might make AI accessible to everyone. Right now, training those big, powerful AI models takes massive computing resources, like huge server farms and special hardware. But peer changes things up. It's not about brute force computing anymore. It's about having a clever design and being able to find information efficiently.
So you're saying that instead of needing a supercomputer, you could train a powerful AI on something much smaller.
Yeah, exactly. And that opens up so many possibilities. Researchers, developers, even regular people who don't have access to all that fancy equipment could start playing around with and building really cool AI models.
It's like everyone has a chance to get in the game,
Right.
and that can lead to tons of new ideas and discoveries as more people are able to get involved.
It really could. And this accessibility could lead to a huge burst of creativity and discoveries as more people can actually contribute to the field.
It reminds me of when personal computers first came out. Suddenly, anyone could create and explore using technology that used to be only for big institutions.
I like that analogy. And just like personal computers changed so many industries, making AI accessible to everyone can have a huge impact on all kinds of fields.
That's so cool.
hmm
But besides making AI more accessible, what about the AI models themselves? How might this new approach change the way AI evolves in the future?
Well, one really interesting possibility is that we could develop AI that actually learns throughout its entire existence. Right now, most AI models are trained on a specific set of data, and once they're done training, their knowledge is pretty much set.
So it's like they go to school, learn everything they can, and then never open another book.
Yeah, exactly. But with a system like Peer, the AI is always talking to this huge network of experts, always learning new things and refining what it knows.
So it's not just about learning stuff, it's about always updating and adding to that knowledge as new information comes along. It's like having a team of super smart advisors who always have fresh perspectives.
Exactly. And that opens up all sorts of possibilities for AI applications that need to adapt and handle situations they've never seen before,
Yeah.
like self-driving cars that can figure out how to drive in unexpected road conditions, or medical AI that can diagnose really rare diseases based on constantly updated medical knowledge.
Wow, those possibilities are incredible.
Right.
This whole idea of a network of specialized experts makes me wonder if it tells us anything about how our own brains work.
That's a great point. There's actually a big debate about whether the human brain works as a single general processor or as a bunch of specialized modules that each handle different things.
So are we like one big neural network or more like a network of smaller connected ones?
Right. And some researchers think that the success of Peer using all those tiny experts supports the idea that our brains might actually function like a biological mixture of experts.
So maybe we're not so different from these AI models after all.
It's definitely something to think about. As we keep exploring AI, we might actually learn as much about ourselves as we do about artificial intelligence.
That's why I love these deep dives. We start with a single research paper and end up thinking about the nature of intelligence itself.
That's the amazing thing about exploring knowledge. The connections, the insights, the questions that pop up, it all leads us to think about the biggest mysteries out there.
Well said. And to all our listeners, thank you so much for joining us on this journey into the world of million expert AI models. We hope you enjoyed it as much as we did.
Keep exploring, keep asking questions, and keep diving deep into that amazing world of knowledge. We'll see you next time.